my name is Vani Sharma, and I'm a Senior Product Manager at Wallaroo Labs. This is part one of the Assay video series. In this video, I'm going to demonstrate how to analyze data that is received or returned by machine learning models during an inference. You can try this tutorial using our free Wallaroo Community Edition linked below. Monitoring tasks called assays monitor a model's predictions or the data coming into the model against established baseline. Changes in the distribution of this data can be an indication of model drift or of a change in the environment that the model trained for. This can provide tips on whether a model needs to be retrained or the environment data needs to be analyzed for accuracy. This allows you to intervene and retrain a model in an efficient and timely manner. A data drift can occur due to errors in the data processing pipeline or due to changes in the environment, such as user behavior. Wallaroo provides assays through both the Wallaroo dashboard user interface and the SDK. This video will go over the basics of assays, the settings, and prepare you to create your own assay. To explore these and other features, check out the Wallaroo documentation site at docs.wallaroo.ai. For other tutorials showing how to use Wallaroo for your machine learning operations, check out the Wallaroo tutorials repository at GitHub. Assays and analysis require a history of inferences. You need a set of inference results before you can start analyzing whether a set of data is valid or not. Assays are based on the following information and settings. Baseline. A baseline provides a set of records where the data is known to be typical. This is how we can determine whether the distribution of the new data has changed. Schedule. New assays are configured to run a new analysis every 24 hours, starting at the end of the baseline period. This period can be configured through the SDK. Scheduled period or assay window. This is the data that is analyzed against, the baseline. Assay windows are based on the width, the period of data that is being analyzed, and the interval, which means how often the assay is run. By default, the width and the interval are set to 24 hours, but these can be adjusted. In this example, the width is set to 24 hours and the interval set to 12. So every 12 hours, the previous 24 hours of data is analyzed against the benchmark. Number of bins. This sets the number of bins that will be used to partition the baseline data for comparison against how future data falls into these bins. By default, the binning scheme is percentile based and is set by the bin mode. Bin mode. This indicates the binning scheme set to quantile by default. Quantile binning defines the bins using percentile ranges. Equal binning defines the bins using equally spaced data value ranges like a histogram. Matrix. The assay uses two matrices to compare the new data against the baseline. The default is PSI, Population Stability Index. This is an entropy-based measure of the difference between distributions. Other measurements are the maximum difference of bins, which means the maximum difference between the baseline and current distribution. And the last metric available is the sum of the difference of bins. This sums up the difference of occurrences in each bin between the baseline and current distributions. Threshold. The threshold decides whether the difference between distributions as evaluated by our metric is large or small. The default of 0.1 is generally a good threshold when using PSI as the metric. In other videos, we will explore how to use the Wallaroo dashboard to create an assay and view the analysis, and how to use the Wallaroo SDK to dive even deeper into the data. Don't want to wait? You can find out all about Wallaroo assays through the Wallaroo documentation site at docs.wallaroo.ai. A full tutorial with sample data and ML models is available from the Wallaroo tutorial repository at GitHub. Thank you for watching and welcome to Wallaroo.